We see many things around us, like photo frame, water bottle, pen, etc. They are all made up of different parts. It is the same with numbers. Let us consider number 6. It is formed by the multiplication of 2 and 3. Similarly, if we consider number 10, it is formed by the multiplication of 2 and 5. Such numbers whose multiplication gives the number itself are called the factors of that number. Sometimes we need to break a number to find those numbers whose product is the given number. That is, we need to find out the factors of that number. The method of breaking a number to find the factors is called factorization. Let's factorize the number 40. Can you express 40 as a product of two or more numbers? Try it. Upon trying, you must have understood that 40's factorization can be done in different ways, like 2 multiplied by 20, 4 multiplied by 10, 5 multiplied by 8, etc. What does it tell you? We can say that the factorization of a number can be expressed in different ways. 40 has another interesting factorization. 2 multiplied by 2 multiplied by 2 multiplied by 5. Can you tell what its speciality is? You got it right. In this factorization, all are prime factors. This way of expressing a number in prime factors is called the prime factorization. Keep in mind that the factorization of a number is to break that number into smaller numbers. On the other hand, the prime factorization of any number is to break the number in prime factors. Now the question is, how to do the prime factorization? Let's learn an interesting way to do it. Let us assume the number as a tree whose prime factorization has to be done. Just like a tree is divided into branches, in the same manner, we will find a pair of factors whose product will be that number. Similarly, just like the branches of the tree are divided into smaller branches and finally into leaves, we will express the factors into smaller factors. At last, we will reach a stage where leaves cannot be further divided. In the same way, we get into this situation by obtaining small factors where we cannot express any of them to smaller factors. At this stage, we get the prime factors of the given number. Isn't it an interesting method? Another way of doing the prime factorization is the division method. Let's understand it. Let's find out prime factors of 40. First of all, draw all images as shown in the screen. The prime factorization of number 40 has to be done, so we will write it in the second column of the top row. Now, we will choose the smallest prime number which completely divides 40. By applying the divisibility rule of 2, 40 can be completely divided by 2. So, we will write 2 in the first column of the first row. On dividing 40 by 2, the result will be 20. We will write it under 40 in the second row. Again, we will find the smallest prime number which completely divides 20. Since 2 completely divide 20, we will write number 2 in the first column of the second row. 10 is the quotient of 20 by 2. So, we will write it in the second column of third row. In the same manner, we will divide 10 by 2 and write 5 in the second column of next row. Then, we will divide 5 by 5. At the end, we get the number 1. All the number of column 1 are the prime factors of 40. Therefore, we will write 40 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 5. Today we have learned the prime factorization. In the next video, we will learn it in a better way with some examples. A puzzle game is going on in a classroom. The teacher has written a puzzle on the blackboard. The puzzle is, I am the smallest number having 3 different prime factors. Tell me, who am I? Ajay's reply is 6, Vijay's reply is 105 and Namrata's reply is 30. In your opinion, who gave the correct answer? Let's read the puzzle once again. I am the smallest number of 3 different prime factors. Tell me, who am I? That means we have to find out the smallest number with 3 different prime factors. Now, to find out the smallest number, the prime factors should be small. But they must be different at the same time. So we will choose 2, 3 and 5. To find out the smallest number, let's multiply them. Therefore, the result of 2 multiplied by 3 multiplied by 5 is 30. So we can say that Namrata gave the correct answer. Next example, find out all the prime factors of 120. Prime factorization is the method of expressing any number into its prime factors. Let's do the prime factorization of number 120. In order to do this, we can choose any method between factor tree or division method. Let's use the factor tree method here. First of all, we will find out the factor pair of 120 whose product is 120. There can be many such pairs like 4 and 30, 8 and 15, 5 and 24, etc. If you feel any difficulty to find the factor pair, then you can use divisibility rule to find it out easily. Please read these rules by stopping the video. Since the end digit of number 120 is 0, this number can be divided by 10. Which means one of the numbers among factor pair of 120 is 10. To find out the second number, we divide 120 by 10. By doing so, we get the second number of the pair, which is 12. As you can see, both 10 and 12 are composite numbers. So, we can express them in their factor pairs and extend factor tree. Can you find their factor pair? Think about it. Let me tell you. 2 and 5 is the factor pair of 10 and 3 and 4 is the factor pair of 12. Since 2, 3 and 5 are prime numbers, they cannot be divided further. Which means the branches of factor tree cannot go further. But number 4 can be definitely divided. The factor pair of this is 2 and 2. Thereafter, the branches cannot be extended. Now we can express 120 as 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5. In this way, we have found the prime factors of 120. Therefore, to find the prime factors of any number, divide it into the branches until we get all the prime numbers. Next example, which of the following numbers has both 2 and 3 as prime factors? To find the solution of the given question, we have to do prime factorization of 84 and 105. Let's first do the prime factorization of 84 by division method. In this method, we divide the number with the prime numbers like 2, 3, 5, 7, etc. again and again. The smallest prime number is 2. Since 84 is an even number, it is divided by 2. On dividing 84 by 2, we get 42. On dividing 42 again by 2, the result will be 21. 21 is not divisible by 2, so we will check the divisibility by next prime number 3. Since the sum of the digits of number 21 is 3, which is divisible by 3, therefore 21 is also divisible by 3. On dividing 21 by 3, we get 7. Since 7 is a prime number, we divided it by 7 only. In the last stage, we will get number 1, which shows that we have found out all the prime factors of 84. Therefore, 84 can be expressed in prime factors as 2 multiplied by 2 multiplied by 3 multiplied by 7. Now let's find the prime factorization of 105. In order to do this, let's use factor tree method. So, for 105, we will find a factor pair whose product is 105. 15 and 7 is one such pair. Similarly, factor pair of 15 is 3 and 5. Since there are prime numbers at the end of all branches, we can say that the factor tree of 105 is complete. Therefore, we can express 105 as 3 multiplied by 5 multiplied by 7. As you can see, both the numbers 2 and 3 are the prime factors of 84 only. So the answer of the given question is 84. Today we saw some examples of the prime factorization. In the next video, we are going to see some misconceptions and common mistakes related to prime factorization. Misconception 1. Which factor tree represents the prime factorization of 30? While representing factor tree, sometimes addition operation is used to find the factor pair. Like in option 1, the addition of 10 and 20 is 30. Similarly, the addition of 5 and 5 is 10. This is an incorrect way of representation. The correct way to perform this is to find those numbers whose product gives the same number. Therefore, the correct answer is option 2. Sometimes number 1 is also included in the factor tree. It is important to understand that the factor tree is created to obtain the prime factors. Since 1 is neither a prime number nor a composite number, option 3 is also an incorrect answer. Now let's see some common mistakes related to prime factorization. Sometimes factorization and prime factorization are considered the same. With this wrong understanding, when asked to find the factors of 18, the answer given can be 1, 2, 3, 6, 9 and 18. And when asked to find the prime factors of 18, and the answer given can be 2, 3 and 3. For a clear understanding, it is important to know the difference between factorization and prime factorization. Factors obtained by factorization method can consist of both prime and composite numbers. But the factors obtained by the prime factorization method can only be prime numbers. Today we saw some common misconceptions and mistakes related to prime factorization.